Hi, everyone, and thanks for joining me for episode 796 of People Behind the Science. This week, we are revisiting our interview with our guest, Dr. Marcia Bjornerud. Listeners, Marcia is a structural geologist who studies the deeply eroded roots of mountain belts and ancient plate boundaries to better understand the long-term effects of tectonic processes and rock deformation in Earth's deep crust. She spoke more about her background as well as her research in our interview. So I hope you are ready to explore the life and science of another researcher in this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of the People Behind the Science podcast. Today, I'm delighted to introduce you all to our fabulous guest, Dr. Marcia Bjornerud. So, Marcia, thanks so much for joining us today. How are you?
I'm well, thank you.
Wonderful. We are excited to have you with us on the program today. But before we talk about some of the details of your work, I would love to give our listeners just a little bit of background. So, listeners, Marcia is a professor of geology and the Walter Schober Professor of Environmental Studies at Lawrence University in Wisconsin. In addition, she is a writer for Elements, the New Yorker's science and technology blog, and she is also author of the textbook, The Blue Planet, An Introduction to Earth System Science, as well as the popular science book, Reading the Rocks, The Autobiography of Earth, and also the recently released book, Timefulness, How Thinking Like a Geologist Can Help Save the World. Now, Marcia received her bachelor's degree in geophysics from the University of Minnesota-Minneapolis, and she was awarded her master's and Ph.D. degrees in structural geology from the University of Wisconsin-Madison. Marcia then conducted postdoctoral research at the Byrd Polar Research Center at The Ohio State University, and afterwards she worked as a contract geologist for the Geological Survey of Canada and the Norwegian Polar Institute. Before joining the faculty there at Lawrence University, Marcia served on the faculty at Miami University in Ohio. Now, she has received many awards and honors over the course of her career, including being named a Fellow of the Geological Society of America, receipt of 2 Fulbright Senior Scholarships, as well as being awarded the Outstanding Educator Award from the Association of Women Geoscientists. And in our interview today, Marcia is going to speak more about her experiences in life and science. So, Marcia, we want to start first by talking about your life outside of science. So can you tell us how you like to spend your time when you're not very hard at work?
Well, I'm a northerner and I really do like winter. So one of my pastimes is cross-country skiing. And I've done a long ski marathon, the American Birkebeiner, several times. It's 50 kilometers long and it runs in February. Although in the last few years, we've had touch and go with enough snow. But cross-country skiing is really one of my passions.
Very cool. So how'd you get into cross-country skiing?
I think it's probably in my genome. I have a Norwegian background and they say Norwegians were born with skis on their feet.
I love it. So what occupies your time in the summer? How do you get outside and have fun in the summer?
Well, I'm a bit of an urban forager. I love berry picking and picking wild grapes and making jams and preserves that we can then enjoy through the long winter months.
Fantastic. Well, Marcia, great to get some insight into your life outside the world of science, but I would love to talk about your work next. So how do you describe what you do to someone who's maybe not very familiar with geology or the specific research that you do?
Well, my field is structural geology, which generally means nothing to anyone outside the discipline. And so sometimes I tell people that I watch mountains grow, which takes a lot of patience. What I mean by that is I try to study the deeply eroded roots of mountain belts and ancient plate boundaries so that we can get a sense in something like real time of the long-term effects of tectonic processes. So we can't really see what's going on inside the guts of the Himalaya, say, today. But if we look at places around the world where ancient mountains grew and have now been eroded down, we can get some insight into how rock deformation in the deep crust occurs.
Very cool. Well, I'm excited to talk more about this work as we go through our interview, Marcia. But I do want to take a moment here right at the beginning to talk a little bit about motivation. I think as a scientist, sometimes things can be overwhelming, trying to balance research and teaching and all the different things you have to get done in a day. And I know myself, I'm always looking for more motivation, and I'm sure our listeners are as well. So do you have a favorite quote or a saying or something that really keeps you going?
Well, I do have something that, again, comes from my Norwegian background. There's a very pithy, short saying. I'll say it in Norwegian and translate it. It's ting tar tid, and it just means things take time. And I think it's a good reminder for those of us who are always multitasking and impatient to get things done. It certainly is geologically true that things happen by small increments, and over time they will accrue large results. So I try to remind myself of that, and I think it's just a good model for working incrementally, breaking big tasks into small parts, and having the faith that indeed you're making progress.
Certainly, and definitely appropriate for geology, like you said, but I think science in general, writing grants takes time, making discoveries takes time. You can't underestimate the importance of that.
That's right. And I think it's a good lesson for students, too, who want to jump in quantum leaps ahead. And you have to remind them it sometimes takes baby steps.
Right. Well, I love it. So we talked about a little bit about this saying that motivates you, but I'd love to hear next about some of the people who might have had a big impact on you over the course of your career. So do any role models or maybe inspirational figures jump up in your mind?
Well, I came through geology at a time when there were very few women mentors. I was reflecting on this and realized I had only one female professor in both undergraduate and graduate school in the geosciences.
Oh, wow.
And she was a pioneer and an inspiration, but I think it was someone at the University of Minnesota, Peter Huddleston, who's a structural geologist, who really opened my eyes to how physics could be applied elegantly to the study of unruly things like mountains and volcanoes and made me shift my focus from more pure physics to geology.
Interesting. Well, great to hear about one of these people who had a big impact on your career. And I think this is still a challenge today where a lot of the students are finding that they don't have a lot of women role models in science. Is this something that you're kind of actively working on?
Well, I hope by example I am. I teach at a small liberal arts college, and here we have right now, as it happens, probably 70% women in our major.
Oh, wow.
That hasn't always been true, but I think at a place like this, a few critical mentors can make a large difference, but we still have a long way to go in the field in general.
Certainly. And we've talked just a hair about your research and some of the great things that you're doing, but I'd love to hear a little bit about how your curiosity was first sparked. I think hearing the beginning stories of scientists is always cool because people come from so many different places and have these different experiences that lead them to want to pursue science. So, Marcia, what really got you curious and interested in science?
Well, I think I had an early latent interest in science. I vividly remember seeing a film in perhaps the first grade of Surtsey, which was an island that was just being born volcanically off the coast of Iceland in the 60s, and seeing the chutes of steam and black ash and cinder coming down and realizing that the earth is alive in some way. But I have to say that I had 10 subsequent years of rather uninspired elementary, middle, and high school science. And when I had arrived in college, didn't really think of myself as a science type, but I was lucky enough to take an introductory geology class, and that latent spark was sort of reignited for me. And I think that's true of a lot of geologists because geology is not represented in most high school curricula the way that physics, chemistry, or biology are. Mm-hmm. Very few people come in the door knowing that geology is a legitimate, vibrant, intellectual subculture in the sciences.
Right.
Most of our majors, in fact, come to us the same way that I entered the field, which is by accident almost, taking the course on a whim or because they have to have a lab science. Once they find it, they're passionate about it. So sometimes we're lucky because we have so many people who have come to the science for the sheer love of it.
Absolutely. So do you remember what was it about that course, or was there a moment where you were maybe doing something hands-on or something particularly cool where you decided, hey, this might be for me?
I think it was the huge explanatory power of geology. I've always liked word origins, and in a way, I think of geology as the etymology of the whole world. It explains everything, how things came to be. And I think it was on some early field trips where we were looking across the landscape and learning to see essentially in 4 dimensions, see the landscape in time as well as space, that I really got hooked. It's a lens through which to see the world.
Very cool. Great to hear about how you started in geology. But I'm curious to hear next, Marcia, about some of these key steps, how you went from this curious student starting to get into geology to where you are today. What are some of these key moments that helped you get to where you are in your career?
Well, I was lucky enough to be able to jump into a long-term project that my academic advisor in graduate school had on the island of Spitsbergen in the archipelago Svalbard, north of Norway. And I guess it appealed to me partly because of my proclivity for austere northern places, but it was also an opportunity to do some really fundamental mapping of the bedrock in a place where there really weren't any geologic maps. So I feel very lucky to have been involved in a project that was one of the last of its kind to create the first detailed geologic maps of part of the Earth. And that was a very challenging thing because we went in with very little idea of what would be there. You just had to have open eyes and senses and really use all of your scientific instincts to create a working map, but also a working hypothesis about how the very complexly deformed rocks there got that way. So I think that laid a good groundwork for me. I had to be a real generalist early on, and that allowed me to be flexible as I've gone forward, having the courage to venture into cognate areas of geology that I would have to learn about before I could go into them.
Certainly. And can you tell us a little bit about some of the positions you've had and maybe specifically what brought you to Lawrence University?
Well, I had taught and, in fact, had tenure at Miami University, which is a very good school in Southern Ohio. Mm-hmm. But I guess I missed winter, frankly. So I made a big change going from a school that had Ph.D. students in our field and a much larger faculty to a very small liberal arts college, Lawrence, in which we have just 3 of us in the geology department. So we have to span a very wide disciplinary space. And of course, we don't have graduate students either. So I value both experiences, but I think being here at Lawrence, I've been able to embrace my sort of liberal arts core. And in fact, we have to teach a wide variety of courses, including a great works course. And that has led me to realize that there aren't enough good popular science texts in geology for people who really want to do more than just study about dinosaurs or learn rocks and minerals, but who really want the whole narrative of Earth history. So that has led me to write my 2 books for popular audiences, Reading the Rocks and Timefulness.
Phenomenal. And I think just the idea of writing a book while balancing teaching, while trying to do research, all these things is daunting to a lot of scientists. So can you tell us a little bit about this book writing experience and maybe how you survived it? It's
very much part of my teaching because in teaching, you develop kind of a full dictionary's worth of metaphors and analogies and ways of explaining scientific concepts to people who may consider themselves science phobic, especially in introductory courses. So my teaching has really helped me as I think of how to craft these narratives in the books for popular audiences.
Excellent. And I know in addition to writing books, you're working on some cool research. So is there a particular project that you have ongoing at the moment that you are just the most excited about, Marcia, and want to tell us about?
Well, yes, I'm particularly interested in a very arcane rock type. It's called pseudotachelite, but what it represents is the only diagnostic evidence of ancient earthquakes. So we know that earthquakes happen all over the world all the time. And we know that there are many, many ancient fault zones, but it's only relatively recently, say in the last 15 or 20 years, that geologists who study deformed rocks have been able to recognize the records of ancient seismic events. So some faults can slip without causing earthquakes, and they leave behind broken up rocks. But this particular rock type, pseudotachelite, is actually generated by frictional melting during a faulting event, and that can only happen when the faulting was at seismic slip rates, meaning something like meters per second or faster, because otherwise the heat, the frictional heat, would be dissipated away. So rock experimentation has shown us that if we see evidence of this frictional melt, which is then solidified as a glassy looking rock, the pseudotachelite, that's evidence of an ancient earthquake. And that's as close as we can get to the actual source of an earthquake. When an earthquake happens today in real time, all we really have are squiggly lines on seismograms, and we can interpret huge amounts of information from seismic records like that, but we can't really go down to the earthquake source and see what happens. So I'm fascinated by these rocks that have been brought to the surface thanks to erosion, where we can actually see what happened in an ancient seismic event. And more there's been convergence between real-time seismology and the study of these kinds of rocks.
Well, this is fascinating. So I'm curious, Marcia, do you get to do the field work where you're actually going out and finding these rocks? Or if so, how do you find them?
So I've gone all over the world in search of pseudotachelite. My 3 sons have been dragged along with me and are probably the most knowledgeable kids their age about pseudotachelite. Right. So I've studied in Norway and New Zealand, But more recently, with students here, we've been nosing around the North Woods in Wisconsin, where we have the deeply eroded roots of ancient mountain belts and fault zones. And we found at least 2 locations that have really spectacular examples. So right in our backyard here in the Precambrian rocks of northern Wisconsin, we found some great localities that will keep us going for several years.
Wonderful. It sounds like you've been able to do some cool work and definitely travel to great places. But I'm curious, do you have a favorite place that your science has taken you? I think this opportunity to travel not only for fieldwork, but also for conferences is one of the things that many people don't appreciate about careers in science.
That's right. And I think especially for geologists, the field work is a big part of why they went into the field. Again, I feel very fortunate to have gone to the high Arctic regions, especially in the 80s before the effects of climate change were really evident. Mm-hmm. So Svalbard has a dear place in my heart, the archipelago that's in Arctic Norway. And when I worked with the Canadian Geological Survey, I went up to Ellesmere Island in far Arctic Canada. And that is an amazing, remarkable landscape, too. It's actually the furthest north you can go and still be on land. Stunning, empty, glaciated landscape.
Oh, wow.
Sadly, changing very quickly now.
So have you been able to enjoy and explore those areas in addition to maybe the sample collection and work you're doing there? Maybe bring your cross-country skis with you?
We did ski sometimes. We had ice axes and crampons to walk on glaciers. Certainly physically challenging experiences, but also opportunities to develop deep and lifelong connections to people from all cultures and backgrounds.
Excellent. Well, great to hear about some of the places that your science has taken you. And I think so far, Marcia, we've talked about a lot of the great aspects of your career and the wonderful things you're able to do. But we haven't yet touched on some of the challenges and the struggles and the hard times. And I know those are quite prevalent in most science careers today. So do you have a favorite story of failure or challenge, Marcia, that you can share with us today?
I don't know if it's a single moment, but thinking back on what was hard, especially in the early years, I have to say it was the kind of casual, habitual sexism that I and the few other female graduate students experienced back in the bad old days. I think at the time we didn't necessarily realize that's what it was. It was way before Me Too sort of times. Mm-hmm. That certainly made things harder. Science is hard anyway. And when you are just starting out, you don't have a lot of self-confidence. And it just meant we needed to really find inner strength and persevere.
Definitely. So were there any particular things that really helped you endure this challenging situation and some of the sexism you experienced?
I think it was fellow students, some critical faculty people who were more enlightened at that time, and certainly a very supportive family.
Gotcha. And for students out there who might be having similar struggles and similar experiences, do you have any advice that you can give them?
Well, thankfully, times have changed, and most institutions, universities have actual mechanisms for grievances, but also to have peer confidants and also people in positions of authority to whom you can go and talk openly. But this sort of thing just shouldn't be happening these days.
Absolutely. Well, Marcia, I'm so glad you brought up this topic because I think it is sort of an ongoing, continuous struggle, though things are getting a little bit better, I will say. But it's something that I think many of our listeners out there have probably experienced themselves. So thank you for sharing your story. I'd like to talk next, though, about some of your successes. I think in addition to the challenges, there are a lot of really exciting, wonderful moments in science. So do you have a favorite success, whether it was a big one or just a small one that really meant a lot to you that you want to tell us about?
Well, I think there's absolutely a joy in being the first to really describe rocks. So when I did work in Svalbard, I was able to name the actual rock formations, which is, again, something kind of rare these days where most of the globe has been mapped and described in detail. I had the honor of being able to actually propose to the International Stratigraphic Commission the names that would be used for certain rock strata. And I have to say that when I think of my full career, I think some of my greatest successes or the joys that I take are in seeing students succeed. So we've had so many talented students go on into productive and satisfying careers and try to spread the word about science literacy, especially earth science literacy broadly. So I count my students as vicarious successes too.
As you absolutely should, I think, right? Their own scientific children in a way.
Exactly.
Now, you mentioned this being able to name rock formations and strata as a success. And I think that is an awesome part of your job that you're able to do. So can you tell us what were some of the names you chose and why did you choose them?
Well, there are rules. You can't name them for people.
There's no Marcia Rock out there, right?
So they just took the names of places that had names. So points of land, mountains, valleys, that sort of thing. So it's not quite as romantic as it sounds, but to delineate the units and have them then be used by all future geoscientists who work in that area, that was a special honor.
Right. You see them in textbooks and you're like, I named that. No big deal.
Yeah. Or at least in scientific literature.
Absolutely. Well, very cool to hear about some of your exciting successes, and congratulations to both you and your students who are now going on to start their own careers. And we chatted a little bit about your book specifically, but I love talking with guests about what they're reading and if they have recommendations for our listeners. So Marcia, we'll definitely put your books on our book list for our listeners to find. But are there any other books you'd like to recommend for us to read?
Well, I recently finished The Overstory, which is by Richard Powers. It's a novel, and it is an effort, I think, to try to put nature as a central protagonist in fiction. And I found that effort really interesting. A couple of years ago, I'd read another book. It's by Amitav Ghosh, who's a novelist, but this book called The Great Derangement is not a novel. It's a collection of essays in which he challenges writers of serious fiction to write about climate change in a compelling way. He says that it's the great issue of our time, and climate change hasn't really been addressed by serious literary fiction in a convincing way yet. And I think that Richard Powers was kind of rising to that challenge in writing The Overstory, which is about trees and indirectly about climate change, but trying to tell a story in which humans and nature are on par with each other as equal parts of a plot. And I think that's a big paradigm shift. And I think, although people might think, well, fiction and science, they're sort of separate worlds. If we're going to get the public engaged with the big scientific concepts of our time, we need new narratives, and fiction can be part of that. And I think this book, The Overstory, is an attempt to do that. I was very compelled by it. It's a great read. I'm not sure in the end if it completely achieves that goal, but it's certainly a book that's staying in my mind a couple of weeks after finishing it. Another one that I read in the last year or so, it was very dense, by Alexander Humboldt back in the 19th century, called Views of Nature. There's a relatively new translation of it.
Okay.
And Humboldt was just an amazing scientist and naturalist, explorer, and writer. Not as well known or as much read these days as Darwin, probably because he just included absolutely everything. The book is just lush. It reminds me of a jungle in its denseness. But if you take it in small chunks, it's a deep dive into a great scientist's mind, and focuses in particular on his travels in South America in the early 1800s. And the other amazing thing about the book is that the footnotes, which are in a teeny tiny font, like 8-point font, I think, are actually longer than the text of the book itself. It's almost as if he had envisioned the web, and the footnotes would be clickable links, which themselves take you down into ever deeper layers of reflection and observation. So it's a lot. But again, I felt that I had crawled inside Humboldt's very fertile mind as I was reading that book.
I must say that's the first time I've ever heard a book described as lush, but I think that really accurately captures.
Yeah, thick with vines and overgrowth.
Yes. Well, that is wonderful. I will add The Overstory, The Great Derangement, and also this Views of Nature from Humboldt to our book list for our listeners. And we mentioned in the beginning of our interview here today that you have a recently released book that just came out. So I do want to make sure we have a chance to chat about that. So can you tell us a little bit about what this book, Timefulness, How Thinking Like a Geologist Can Help Save the World, is about, and what prompted you to write it?
So the word timefulness I've made up.
I like it.
As a deliberate counterpoint to timelessness, which is an ideal that we kind of strive for. We'd like to think of things as timeless. My point is that everything is timeful in that it is full of an evolutionary backstory. All organisms that are around, including ourselves now, obviously have come down through millions of years thanks to the processes of evolution. Everywhere we look, nature is bursting with narratives. And I think the subtitle might sound a little hyperbolic, How Thinking Like a Geologist Can Help Save the World.
I like it. It makes you sound like a superhero. Yeah.
But I think it is not enough to save the world, but it's a necessary step toward long-term thinking and planning and recognizing how our actions are, in fact, changing natural systems. So it's an explanation of how geologists have come to calibrate time, how we know the rates of processes that we can't really observe in real time, what those are, and then how human activities and the rates of change today that are accelerated by our activities compare with geologic processes. So it's a plea for thinking on longer timescales than we typically do. And I think, unfortunately, just at the time where we need to have long-term thinking, our attention spans are shrinking more than ever. We're obsessed with our constant chimes of digital devices. Congressional terms of 2 years are pretty much as long as we seem to have governmental planning going on these days. Corporations are under pressure from shareholders to have quarterly reports that look good. And we really need to be planning on decadal or longer timescales, and we really hardly have the governmental or economic infrastructure to do that. So it's also trying to envision what a time-full society might look like. And I'm hoping it's at least provocative for people to think in their own lives how they can contribute to a society that has the capacity to take the long view on things.
Absolutely. I think it comes back to your quote in the beginning here. Things take time. And
exactly.
No matter what topic you're speaking of, that's relevant, I think.
It's true. Yeah.
Well, thank you so much for sharing more about this book. We'll put it out there for our listeners to find if they want to read it as their next great read. And we've talked a little bit about some of the great aspects of your career. And one of the things that we haven't really gone into detail on is some of the people you've been able to work with. And I think your fellow scientists are a fun, funny, and wonderful bunch of people, though that's not how we're always portrayed in the media. So I love talking to scientists about some of the quirky and fun things that they do on the job that might be contrary to some of the stereotypes out there that people have. So Marcia, do you have a fun tradition or just a funny memory that you can share with us?
Well, I've worked with all kinds of people, and especially in the Arctic regions. When I started in Svalbard, many of the geologists up there were Russians and Poles. And this was before the collapse of the old Soviet Union, too. So it was amazing to interact with people who were really very much more free in this very remote place than they might have been if they were in their home countries. So really developed a rapport with people from very different cultures and backgrounds and government systems. And one funny example of a collective project that I worked on with scientists in Ellesmere Island that included, again, somebody from Japan, somebody from Russia, some French-Canadian field assistants, a Swiss geologist. And one of our main evening activities would be speaking on the radio with other field camps that were scattered around the Canadian Arctic.
That's amazing.
And off the radio, reception was very bad. Mm-hmm. So you would need to use a radio alphabet, Alpha, Bravo, Charlie, Delta, Echo, etc., to spell words out. But one evening we thought, let's create the most confusing possible radio alphabet. I don't remember all of it, but for N, we had the word new. For G, we had the word new. For K, we had the word new. And for P, we had the word pneumatic, that sort of thing. When you are far from civilization and you have to invent your own entertainment, I guess.
These sorts of things happen. Yeah.
But I feel very lucky to have had these very intense relationships with people who in any other field of work, I probably would not have gotten to know that well or intimately. When you're really in a kind of survival situation, short of being in a military operation, I can't think of other ways you would get to know people that well.
Absolutely. And through these projects that you've mentioned, I think it really highlights this global nature of science, that you're working with people from all over the world with very different backgrounds and different cultures. So can you talk a little bit about some of these projects and what it's like really just being out there in the middle of nowhere with, oftentimes I'm imagining, people who you've sort of just met?
Well, there's an immediate intimacy and lack of pretense when you are grubby and haven't showered for several weeks. You just accept each other as human beings. And that gives me some hope. I do think science is a unifying enterprise. It's a very human undertaking. And I know in my experience, again, with people who I might not otherwise choose as my friends, I have developed these close relationships because of a shared love for understanding nature. And I think if we can share that with more people, then there's some hope of reunifying a very divisive world. So that's part of my hope in writing the book. And in speaking, I do a fair amount of public speaking to different kinds of groups, the Kiwanis, the Girl Scouts, finding a shared humanity in looking outward, not always being so focused on ourselves. Let's look outward. We're all Earthlings. We all share this amazing planet. And if we all knew more about it, maybe we would focus less on our differences.
Oh, I love that you brought out some of your opportunities that you've had to do outreach, because I think these are so important to kind of reach these people who might not otherwise be exposed to science or maybe might not consider science as a career. So can you tell us a little bit more about some of these experiences?
Well, we live in a medium-sized town, so there's opportunities to reach out to groups through schools, through churches, through community groups. And I think once you get on some lists like that, they're shared. So I usually, if I have time, I really do try to make these kinds of connections. And it again helps break down some of the stratification that can keep different groups of people from talking to each other.
Absolutely. And I know we've talked about some of the big questions that you're answering with the work that you're doing, but I think there's always something standing in the way between a scientist and their dream questions or ideal project, whether it's funding or staff or technology or just feasibility, I imagine is a lot of the case in geology. So is there one dream project or big question that you are just dying to answer, Marcia, that you haven't been able to tackle yet, that you would if we could give you everything today?
Well, if you really mean there's no bars on the technology.
Correct.
Traveling back in time, I guess. I mean, for all geologists, we're studying things that have happened in the recent or very distant past. And I do have this kind of yearning to know, are our interpretations correct? Am I reconstructing this mountain belt correctly? Certainly, I would love to know what happened during the great mass extinction events of Earth's history. Not just the dinosaur extinction, but say the Permian event. Those are huge mysteries, and we are always gathering more information. But I really do have a deep yearning to know what happened. So I guess that's verging on science fiction. But if I could go back in time, I would choose several critical moments in Earth's history to really understand what happened, because understanding is relevant to the future. Geology is really as much about the future as the past.
Absolutely. Well, I love this time machine answer. I'm going to challenge you to take it a step farther. If you could pick one moment to go back in time to see, what would you want to look at first?
Possibly the interval called Snowball Earth, which is the deep freeze that happened about 700 million years ago. And some of the rocks I worked on in Svalbard actually were from that period of time. So I've looked at the rock record of that. The question is, was it really a completely frozen snowball planet? Was it more of a slush ball planet? And then how quickly did it end? That's kind of an interval of time. It wouldn't be just one day. I'd have to be hanging around for a few tens of millions of years potentially. But to have a bird's eye view of Snowball Earth at least would be fascinating.
That's awesome. Well, thanks for dreaming big with us today, Marcia, and talking about some of these dream questions that you have. And I think you're absolutely right. There's some fields where, like geology, this time machine would be perfect if only we could get it right, right?
Yeah, not leave behind some telltale piece of garbage or something that then messes everything else up.
Of course. Well, wonderful to hear about some of these big questions in the field that you're still working to address today. And we've talked about some of the people that you've been able to work with. And I think these people can be a great source of advice and inspiration throughout your career. And I'd love for you, if you can, to pass on a piece of advice to our listeners that might help them on their own careers. So Marcia, is there one piece that really helped you that you can give to them today?
I think most of the people I've worked with are not the advice-giving types, but they are people who set good examples. Less prone to pontificate, but more just roll up your sleeves and get the work done nice. So I think just really hardworking, earnest people are the best advice givers in a sense, without even uttering some kind of adage or advice. I could think of bad advice that I've had.
Oh, yeah? What's that?
Take typing so you have something to fall back on. I remember being told that in high school. I was told early in my career as a professor, don't take any time off after I had my first child.
Oh, dear.
Because maybe I would not be seen as being serious about my career. So I didn't. I had him with me 2 weeks after he was born.
Oh, my goodness.
In classes, and that was tough. So sadly, I can remember some bad advice, but I remember a lot of people setting very good examples. And I think that probably speaks louder than words.
Absolutely. I think leading by example is really powerful, because a lot of professors maybe don't realize how closely their students are watching them, whether that makes you excited or nervous. I'm not sure, but
yeah, that's a little scary.
Well, wonderful to hear some of the lessons learned in your career. But is there any other last piece of advice you want to give our listeners today, or maybe a last inspiration you'd like to leave them with at the end of our call?
Well, I think we can all get children interested in nature early and often. And I think that's really where hope lies. If we can get the next generation of scientists engaged early, nurture that very human instinct for being scientists, for just being open to the natural world, we can change things.
I like it. Wonderful message of hope to leave our listeners with today. Can you tell them, Marcia, if they want to learn more about you and the work that you do, where should they go?
They can look for me on the Lawrence University website, and I'm happy to answer email, although not always the same day, but I can be found through Lawrence University.
Perfect. Well, listeners, definitely check out Marcia's work. She's doing some amazing science, and get in touch if you have any specific questions. And Marcia, thanks so much for joining us on our program today to share a piece of your own life in science.
Thanks, Marie.
Well, it's been a pleasure to be with you, and pleasure to have you here as well, listeners. We'll see you next time on another episode of People Behind the Science.